Okay, today's rule is a big one. It's going to completely magnify the number of functions that you're able to differentiate. It's called the chain rule. And before we get into it, let's just talk about what we know so far. You know how to take a handful of derivatives at this point. You know the power rule, which is this derivative of x to the n, which is n x to the n minus 1. Remember, we drop the exponent down and we decrease it by 1. And so an example of that would be like this polynomial, this quadratic down here. The derivative of this would be 8x minus 3 because the 2 drops down, multiplies by the 4, and decreases to a 1. And then the derivative of anything x is just that number. We also know some trig. We know the derivatives of all of the basic 6 trig functions. The derivative of tangent is secant squared, for example. The derivative of secant is secant x tangent x. The thing that these all have in common is that the thing getting raised to the power is just an x. Just an x getting squared, just an x. So other than the exponents and the coefficients, we have just an x. The thing that we are taking the tangent of, just x. The thing we are taking the secant of, just x. And then our result is just in terms of x. All right, everything's nice and simple now. Everything's just a single x. And so that's what we're going to change up today. So technically, we have rules that would look like these at the bottom if you were to look in the front cover of your book. So what we're going to learn how to do today is, what if I don't just have x squared? What if I have this little miniature polynomial squared? What if I'm not just taking the sine of x? What if I'm taking the sine of 4x cubed, something a little more complicated than x? That's the problem we're going to fix today. If you look these things up, the derivative of u to the n is n times u to the n minus 1 times u prime, or it might be written as times du. Now remember, on that last screen, everything was just an x. So what is the derivative of x? It was a 1. So if the functions in questions are just x's, then that little u prime right there never really shows up because it's just a 1. And you don't have to put a times 1 on the end of a simple derivative because it's just understood to be there. The derivative of sine u is cosine u times u prime, or times du. Same deal. If I was taking the derivative of sine x, it was cosine of x times 1. Today's difference is the derivative of this thing is not 1. So that little u prime is the chain rule. That's where we're going to tack on to the end. We're going to multiply by the derivative of whatever my inner function is, which we'll call u. This one, the derivative of 2x plus 3 is not 1. So when I take its derivative, I'm going to have to tack on the derivative of 2x plus 3 onto the end, which would just be a times 2. Okay, so the chain rule, whatever your inner stuff is, the guts inside, the thing that's getting squared, or the thing that you're taking the sine of, that thing's derivative needs to be multiplied at the end. So let's do some examples. Okay, so you could have taken the derivative of the square root of x before. The square root of x is x to the 1/2, so its derivative would be 1/2 x to the negative 1/2. So here's our first example. We have something else to the 1/2. We have x cubed minus 4x squared to the 1/2. All right, so the derivative of anything to the 1/2 is 1/2 times that thing to the negative 1/2. That's what we would have done according to the rule before you learned the chain rule. The chain rule says we have to multiply to the end of this expression the derivative of the inside stuff, the derivative of the guts, 3x squared minus 8x. And this is the derivative of this function, square root of x cubed minus 4x squared. Okay, it's not complete until you have done the chain rule, and this part out here is the chain rule. And now to kind of clean it up a little bit, I would probably write this like 3x squared minus 8x over 2 times the square root of x cubed minus 4x squared. That's a negative 1/2, which means it can go to the bottom, and I'd rather write it as a square root than as a 1/2 power. Okay, that's our first chain rule. The thing that was being raised to the 1/2 power was more complicated than x, meaning it had a derivative that was other than just 1. Okay, let's go down here to g of x. We have something cubed. The derivative of something cubed is 3 times that thing. Don't change it right here. This should be exactly the same as this. Don't change it there. Okay, but it's 3 times that thing squared times 6x squared. That's the derivative of the inner guts, the u. If we were writing this thing out, the derivative of u cubed is 3u squared times u prime. So u is 2x cubed minus 4. I have 3u squared times u prime. All right, this is how the chain rule works. And it's not an equal, I'm just underlining that too. I would probably clean this one up a little bit by saying 18x squared times 2x cubed minus 4 squared. And you could multiply that out if you wanted to, but this is good enough. All right, a couple trig ones. Now, here's how this gets a little tricky. You have to now distinguish, is this a power rule where your u happens to be trig, or is this a trig rule where your u happens to be a power? This is the same as sine of x squared. Okay, we just put the squared on the inside so we don't confuse it with something like this next example. The derivative of anything squared is 2 times that thing to the first, and you can put that 1 there or not, I'm putting it now to be clear, times the derivative of that thing, that inner u. The derivative of sine is cosine. So my answer is 2 sine x cosine x. All right, something squared is 2 times that thing to the first, but you have to remember to tack on that derivative of that thing. All right, u is sine x in this case. Now, we also have a rule for derivative of sine of something. In this case, u is x squared. The derivative of sine u is cosine u times u prime. Okay, so the derivative of sine of x squared is cosine x squared times 2x, or 2x cosine x squared. All right, make sure you understand the difference between those last two. The top one is a power rule where u just happened to be a sine. The bottom one is a sine rule where u just happened to be a power. All right, and it's just the order in which you do things. The order, it all depends on what u is to make the chain rule happen. All right, so here's another couple of examples. Think about, is it a trig derivative or is it a power rule where it just happens to have a trig as its u? Pause for a second and take a stab at these two, see how you can do, and then come back for the answers. Okay, so in this top one, cosecant of something. The derivative of cosecant is negative cosecant cotangent. So our rule, if we looked it up, would look like this. The derivative of cosecant u is negative cosecant u times cotangent u. Okay, so if our u is pi x plus 1, our derivative of that thing is negative cosecant of the same argument times cotangent of the same argument times, oh, I forgot it up here, times u prime. U prime, if the derivative, or if the u is pi x plus 1, the derivative of that is pi. Pi is a constant, just like if it were a 2. So you could move that pi to the front, you could leave it at the back, probably would be at the front in a multiple choice answer, but as long as you've got it in there, you're good. All right, that's a trig where the derivative of pi x plus 1 has to be tacked on to the end. All right, so we have another one down here. We've got a power rule. In this case, u is tangent. Okay, something to the 3/2. You could have taken the derivative of x to the 3/2 before you ever started this video. It would be okay, so this u happens to be tangent of x. So f prime, the derivative of f, is 3/2 times tangent x. 3/2 minus 1 is 1/2 times the derivative of the inside stuff. The derivative of tangent is secant squared x. Okay, so that one could be cleaned up a little bit too. You could call it a square root, but we'll just leave it like this for the time being. All right, there's two good examples. Let's move on. All right, so here's where it gets real interesting. Mr. T here, that's Clubber Lang from Rocky 3. You should check it out. The sine of something, that something is 3x plus 2 quantity squared. Okay, so let's just start on the outside. The outermost thing that's happening here is this is a sine derivative. The derivative of sine of anything is cosine of that same thing. Now, today we're learning that we have to tack on the derivative of that inside thing. This inside thing is 3x plus 2 quantity squared. So if you can see, hopefully you can predict why this is called the crazy one, because this thing itself is a chain rule. So this, you could call it a double chain rule or a nested chain rule, or it's probably got a more technical term. But the derivative of this thing is itself a chain rule. All right, the derivative of this thing squared is 2 times 3x plus 2 to the first times the derivative of 3x plus 2. That's times 3. Okay? All right, so check that out. Let's review it. The derivative of sine is cosine. Then starting here, this is the derivative of this. So I have a u kind of within my u. And the derivative of something squared is 2 times that something to the first times the derivative of that something. And that's where the 3 comes in. All right, so if it's nested like that, you're going to have to do a two-stage chain rule and then kind of clean it up when you're done. I'll say the 2 and the 3 make a 6. The 3x plus 2, I'm just going to leave cosine of 3x plus 2 quantity squared. So there is our derivative, okay? So don't, it's tricky at first until you get good at it, but don't overthink it. I'm taking the derivative of sine, and then I'm taking the derivative of this. And one slide ago, if I said, hey, what's the derivative of this? I think you would have been fairly confident saying it was this. Now that's just within a bigger question. So a question within a question, as long as you can sort it out, is not too bad, but they're a little tricky. So let's do a little bit more like that. Okay, so give this one a shot, pause and try it. The outermost rule here is something square rooted, which is something to the 1/2 power. Okay, the derivative of anything to the 1/2 is 1/2 times that same exact thing to the negative 1/2 times the derivative of that inside thing. All right, the derivative of cosecant is negative cosecant of pi x cotangent of pi x times the derivative of that inside thing, and that's just a pi. So you get that extra constant of pi tacked on because the u, when we did the du where that was the u, that itself was a chain rule, just like the last example. So to kind of clean this one up a little bit, I would do, let's see, I would do pi over 2 to combine the constants. On top, I'm going to have, I'm going to move the negative from the cosecant term out to the front also. I'm going to have cosecant pi x, cotangent pi x over the square root of cosecant pi x. And I guess I should go ahead and combine those two. If I have cosecant over the square root of cosecant, that's really just the square root of cosecant on top. And there we go. All right, so there's another nested one, another 2 in 1. So take your time on those. Be careful with them, and you should be all right. All right, one more little thing. Okay, so what I want to caution you from is over chain ruling. We've seen several examples where you have to apply the chain rule once and tack that derivative onto the end. We've seen a couple of examples where the chain rule itself involves a chain rule, so you have to tack an additional chain rule onto the end. Here's what I want you to watch out for. Make sure you don't do this. We should approach this one like this. The derivative of cosine is negative sine of the exact same expression. Now, the chain rule says this expression on the inside I have to multiply by its derivative at the end. So the derivative of everything inside the signs parentheses is 4 times x cubed plus 2x squared to the third. All right, because I dropped the 4 down and I decreased it to a 3. And because I was taking the derivative of this, that involved a chain rule. Okay, the sign, the original involved a chain rule, and this inside one involved a chain rule. So the derivative of this green underlined stuff is 4 times that stuff cubed times the derivative of that stuff. The derivative of that stuff is 3x squared plus 4x. All right, would you agree that the derivative of this is 3x squared plus 4x? Here's what you don't want to do. A lot of times people will just keep on chain ruling until eventually it turns into nothing. Okay? The derivative of that was 3x squared plus 4x. So then people will think, okay, well, the derivative of that is 6x plus 4. And the derivative of that is 6. And the derivative of 6 is 0. And eventually the whole thing just wipes out to 0 because they just kept on incorrectly chain ruling. You need to stop when the derivative that you take from here to here does not involve the chain rule. Before you ever knew the chain rule, you could have taken the derivative of this, correct? This is 3x squared plus 4x. That doesn't need the chain rule, so when I do that derivative to go from here to here, you don't just keep on going. All right? You will occasionally have a double, like this one in the last couple of examples. You'll have a lot that just happened to chain rule once. But if you find yourself chain ruling over and over, especially if you end up with a times 0 on the end, you've probably over chain ruled. So careful for that. Don't make that mistake. All right, this is an important one. Put a lot of practice in on this one. And I think it's going to be a real highlight of your life.